Hey there! In this video, I'll share with you how to use simple mathematical reasoning combined with underlying theories in order to determine the volume of gas liberated at the anode during an electrolysis process. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. In order for us to understand this kind of question, we need to know something about the preferential discharge of ions at the electrodes. From the question, we know that the electrolyte is a concentrated solution of sodium chloride, which means there are two ions that are approaching the anode. The chloride ions from sodium chloride and the hydroxide ions from water. But the chloride ions will be discharged in preference because they are in the higher concentration. Writing the half equation for the oxidation process taking place at the anode gives us one chloride ion losing an electron to become a chlorine atom, but the chlorine atoms will move on to form diatomic molecules because as atoms they are unstable, which means we need a 2 in front of the chloride ion and a 2 in front of the electron in order to balance the half equation. This half equation gives us two further details that we need to know in order to complete our solution to the problem. That is, the amount of electricity required to liberate the given amount of chlorine gas in the half equation, which is, we can say, 1 mole. 1 mole of electrons require 96,500 coulombs. So 2 moles will require 193,000 coulombs of electricity. We also get the volume of gas liberated at room temperature. 1 mole of any gas will occupy a volume of 24 dm cube at room temperature and pressure. This is 1 mole, so we can simply write that 1 mole of chlorine gas will occupy 24 dm cube, which is the same thing as liter, at room temperature and pressure. In our next step, we will use simple mathematical reasoning in order to determine the amount of electricity that were used in the electrolysis process. We will use simple if and then statements. If 193,000 coulombs will liberate 24 dm cube or liters of chlorine gas at RTP, then an unknown amount, we'll call that X, will liberate, and this comes from the question, 60 dm cube of chlorine at RTP. Solving for X is equal to 193,000 times 60 divided by 24, which is 482,500 coulombs. And finally, we will use the equation coulombs of electricity given by the symbol Q is equivalent to quantity of electricity. In the question we're given that amount to be 2 amperes times time, and time will be given in seconds. So making time the subject of the formula, time is equivalent to 482,500 divided by 2, which is 241,250 seconds. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to combine underlying theories with simple mathematical reasoning in order to determine the volume of gas liberated at the anode during electrolysis. Good luck on your exams, and I'll see you next time.